context-free grammar. Whenever we are saying that V, T, or P, they are sets, we refer them as a finite sets. So basically, V, T, P are nothing but the finite set of variables, terminals, and production rules. Here, one grammar is given to you, which consisting of S, A, and B as a variable. So we can write it like V is equals to S, A, B, which is nothing but finite set of non-terminals or variables. T stands for finite set of terminal symbols. All the symbols which are represented here in the form of small letters, likewise A, B, these are nothing but the terminal symbols. We can very well say that T is equals to A comma B. P is referred as a finite set of production rules, which is nothing but these rules which are mentioned here. We in all have 1, 2, 3, 4, 5, 6, and 7 rules available in this finite set of production rules, that is P. And here the starting variable is S. Okay. So this is how we can declare a tuple definition for grammars. Okay. Now, when we are writing grammar, as it is given here, it is not necessary always that the grammar which is available is in the simplified form. That means basically for that we need to go into the root of grammars. Why do we have grammars? Grammars are basically for generating the set of strings which are associated with any particular language. When we say context-free grammars, we are referring to the grammar which generate the set of strings belonging to context-free language. So what does it says? That any grammar should generate the set of strings. When set of strings are generated, but we have multiple variables available in the grammar or multiple production rules available in the grammar, we need to check, does really we read those many production rules or those many variables? Because it may happen sometimes that the grammar which is written may contain some set of production rules or variables or which may not lead to terminal symbols. So basically, whichever grammar rule doesn't lead to generation of terminal, we can refer that with the generalization, we can refer that particular variable or a production rule as a useless. So there are few terminologies which are associated with the grammar, which we must take care while writing a grammar. Those are nothing but the first case is useless symbols. Second is epsilon productions. Third is unit productions. And fourth is useless productions. Now, what does they mean? When we say useless symbols, these are the symbols. Usually we refer them as variable symbols, which doesn't lead to generation of terminal symbols. These are nothing but the non-generating symbols or useless symbols. Similarly, non-reachable symbols. We say that we always start with the starting variable s. But if there exists some variable which is not reachable from the starting variable s, such type of variables can be referred as or symbols can be referred as non-reachable symbols. Our first job is to remove such symbols from the grammar, so that we must have only those symbols available in the grammar which are useful. Then the second case, which is related to terminology, which is related to simplification of grammar, is epsilon productions. Now, what does it mean? Epsilon we know means an empty string, and if any grammar has some set of productions which are not generating anything, it is better to remove such type of productions. So those epsilon productions we must remove. For example, if you see here, B gives epsilon, this production, B gives epsilon available in our given grammar is nothing but the epsilon production. So we need to remove any such productions from our grammar unless our language itself is a one which generates empty string. Okay, in that case we cannot remove the epsilon productions. Otherwise, in all other cases, we need to remove the epsilon productions. Another terminology is unit production, which means the productions which are of this nature. A gives B, where left hand side contains one variable and right hand side also contains one variable. Such production doesn't lead to any new thing. So such production should also be eliminated. Last but not least, useless productions. Any production which is not resulting into generation of a terminal string can be referred as a useless production. So we must remove all such productions from our grammar. So when we say we want to simplify a grammar, basically we are looking for such type of symbols like useless symbols, epsilon productions, unit productions, and useless productions, and we remove all such productions or symbols from our grammar. That process is referred as the simplification of grammar. For the sake of example, let's go for the grammar which is available with us. This. Okay. Here we have said that S is our starting variable. Okay. So let's look for, do we have any useless symbols available in the grammar? If any available, we must remove them. Now the criteria for that is, first is non-generating symbols. That means the symbol which does not lead to generation of terminal symbol can be referred as a non-generating symbols, and such symbols should be eliminated. Let's look for how many symbols do we have here? We have three symbols available, S, A, and B. From S, we have ASA as a one production, AB as another production, and this B leads to epsilon or B, which means this B is a useful, this A also leads to A, so it is also useful. In turns, these are useful fractions or variables in our grammar. Is it clear?
Yes, sir, it's clear.
Yes, any query? So we do not have any useless symbols here. Non-reachable symbols means what? The symbols to which we are unable to reach from the starting variable. So here from S, we are reachable to A as well as B. So none of the variables available here are useless variables or non-reachable variables. Then eliminate epsilon productions. Remove productions that generate empty string. Do we have any production which generate empty string here? Yes, B gives epsilon is a production which generate empty string. How to remove it? We need to look for all the places wherein B is available, and all those places we should remove or replace with epsilon. Okay. Hello, any queries? Any queries about this step number 1? Am I audible to you
No,
all?
sir. Yes, sir.
Okay. Then step number 2 is about eliminating epsilon productions. So in this grammar, we have just one production rule, which is epsilon production. That is B gives epsilon. So what we need to do is we need to replace all the places wherein B is available with epsilon. But at the same time, we need to see, since we have another production also from B, which is B gives B, we need to keep all B variables as they are. So let's look after removal of this epsilon production, that is B gives epsilon, how does our grammar changes? So this B is available here as well as here, these two places. Let's remove them with epsilon, replace them with epsilon. So we have S gives ASA as it is, followed by A, because if this B is replaced with epsilon, we are remained with small a only. Next is A gives, this B is required to be replaced with epsilon, so ultimately A will lead to generation of epsilon, followed by S, followed by A, that will remain as it is. Last but not least, this B will remain as it is, right? Apart from this, here A, B will remain as it is because this B we require for using this B gives small b. Similarly, this B also gives epsilon. So we need ultimately we need this B also. I hope it is clear to you all. Removal of B gives epsilon production from the grammar. But if you observe here, we have A gives epsilon. This also has another production rule, which is an epsilon production. So that also needs removal. So the thing which we did for B, same thing we'll do for A gives epsilon also. So let's try to remove it. We first did for this, same thing we are going to do for A with epsilon also. So S gives SA bar AS, wherein this first A replaced with epsilon, second A replaced with epsilon, followed by ASA. This will remain as it is for these remaining 1, 2, and 3 productions. Okay. Followed by this small a will remain as it is, then AB we will have as it is. Then A gives S bar A bar B and B gives small b. So this is the resultant production 1, 2, and 3 after eliminating epsilon productions from this given grammar. Is this clear with the process? Is this process clear to you all? Good.
Yes, sir.
Next. Now, what is the next process? Elimination of unit productions. So for this purpose, we need to check what are the unit productions available in the grammar. We have S gives SA, S gives AS, S gives ASA, S gives A, S gives AB. So here we do not have any unit productions available. But if we refer productions for A, we have A gives S and A gives B as the two productions which are of unit production style, right? So we need to remove these two productions from our grammar. How to go for it? Let's first focus on A gives S. Okay. If we want to remove this, what will be the resultant grammar? Yes, resultant grammar would be S gives. Now, wherever A is available, that A should be replaced with S. Ultimately, what does it means here? Similarly, A gives B. So A should be replaced with S. A should be replaced with B. Is this clear? Yes or no? Good.
Yes, sir, it's clear.
So A gives S, and from S to go with this is unnecessarily we are having a switch from A to S and S to further. So we'll remove this. Ultimately, let's go for S gives S A bar A S bar A S A bar A bar A B. This we have available with us. Now S gives A gives S and S gives these all. Let's replace them with SA bar AS bar ASA bar A bar AB. This is for this bar. Now this A, if we take, it is same as that of this A gives A. So leave it. We have A gives B and B gives this. So ultimately we can replace this A, B and B transition with that of B. Okay. Last but not least, B gives a small b. So this is basically the production where we are removing the unit productions from our grammar. Do we have any other production rule here which we can treat as a epsilon production? That means the production is left hand side and right hand side both having unit length and both are variable. So I don't feel that we have any such production rule available here wherein we have variables on both the sides. So this is our resultant productions after removal of unit production. Last but not least, elimination of useless productions from the grammar. Now, does there exist any production here which is useless? That means which does not lead it to derivation of a terminal string. S gives A, that means S generates a terminal. A gives B, that means A also generates terminal. B gives B, that means B also generates terminal. So we do not have any production rule here which can be referred as a useless production. So whatever we generated here, this is nothing but the capital P, that is set of production rules equivalent to the original grammar containing no useless symbols, no epsilon productions, no unit productions, and no useless productions. So this is the process of simplification of grammar. If you have any queries, please let me know on this.